So the extra balancing chemical equations, and you can find these extra problems on Moodle. Under the chapter 1, it's right where you got the slides and in-class problems and that kind of stuff. So we're balancing chemical equations. So what we want to do is we want to make sure that we have the same number of atoms of any given element on the reactant side as we do on the product side. So here are our reactants, here are our products. Okay. So what we're going to do is we're going to look at each of the different elements. For example, in this problem, in the first one, I have lithium, I have oxygen, hydrogen, and carbon. And so all those elements are in the reactants, and they are also in the products. So what we're going to do is we're going to count up the number of atoms of each, and then we're going to balance the equation to make them equal. So lithium, if I look at lithium, I only have one lithium atom. That's easy. Oxygen, there's one there, but be careful, when you come down here, you also have two here. So that's 1 plus 2 is 3. Hydrogen, I have one here. And carbon, I have one. So we do the same thing with our products. If you look at your products, lithium, we have one. Hydrogen, we have one. Carbon, we have one. Oxygen, we have 3. So now what you want to do is check. Do the reactants, do the number of atoms of the element in the reactants equal the same number of atoms of that element in the product? And the answer is yes for lithium. Then we check oxygen. Compare reactants to products. They're equal. Hydrogen, reactants to products, equal. Carbon, reactants to products, they are equal. So this one is balanced. We didn't even have to do anything. It was already balanced. You won't see that on an exam. Okay, the next one, we're going to do the same thing. We're looking for all the different elements that are inside of our reactants. So we have hydrogen, we have chlorine, and I'm just kind of going down the line. Hydrogen, chlorine, magnesium. Then we're going to do the same thing over here. We have hydrogen, chlorine, and magnesium. You will always have the same elements on the reactants as the products. So over here I have hydrogen, I have one. Chlorine, I have one. Magnesium, I have one. Do the same thing over here. Magnesium, I have one. Chlorine, I have two. Hydrogen, I have two. Now I look and my chlorine isn't balanced and my hydrogen is not balanced. So I need to decide what to do. Well, I want to bring these ones up to twos. So the way that I do that is I'm going to use a coefficient and I'm going to put it, maybe a different color, a blue, right, in front of my compound. What that 2 now means is that it's multiplied by however many atoms were in there originally. And originally I only had 1. So 1 times 2 is 2. But be careful, we didn't just change the hydrogen, we also changed the chlorine because it's hydrogen chloride. So it's together, or hydrochloric acid, depending on, it's aqueous, so hydrochloric acid. So times 2, we get 2. Do we have the same number of atoms of hydrogen on the reactants as the products? Yes. Chlorine, yes. Magnesium, yes. So we are now good to go. We got that one balanced. Next, now we are looking at iron and sulfur. So we only have 2 elements in here. So if we look on our reactants, we have 1 iron, we have 1 sulfur. Products, we have 2 iron, we have 3 sulfur. So what are we going to do? We need to bring our 1s up. So to bring up my iron, I'm going to multiply by 2 to get 2. So I put a 2 right here. Sulfur, I got to bring it up to 3, so I'm going to multiply by 3, which means I'm going to put a coefficient of 3 right there. And now my irons are balanced, my sulfur's balanced. I'm good to go. All right, they get a little more complicated. All right, do the same thing. Nitrogen, oxygen, hydrogen. Okay, we only have 3 elements. Nitrogen, oxygen, hydrogen. So let's look in our reactants and see what we have. We have 1 nitrogen right there. Now be careful of your oxygen. We have 2 here and we have 1 here. So we have 2 plus 1 gives us 3. Hydrogen, we have 2. Look in your products. Nitrogen, I have 1 there and I have 1 there. So 1 plus 1 gives me 2. Oxygen, I have 3 here, 1 here. So that's 3 plus 1 gives me 4. Hydrogen, I only have 1. So I know now that I'm going to have to bring up my nitrogen, not my nitrogen, my oxygen and my hydrogen. Okay, so what are we going to do? Well, we're looking for elements. When you're trying to decide what to do first, you want to look for elements that are only in one place on one side of the equation. So if I look, for example, at this, it would be really a bad idea to pick oxygen because oxygen's in every single compound in the reactants and every single compound in the products. So we don't want to pick oxygen. That would not be a good place to start. So I want to start with something that's only in one place, my nitrogens or my hydrogens. Either one would be a good place, but my hydrogens are only in one each. So I'm going to pick my hydrogens. So I need to bring my hydrogen here up. So I'm going to multiply by 2. I get 2. So I'm going to put my 2 right here. That's what I had to do, bring up my hydrogen. Now, that 2 affects the hydrogen, affects the nitrogen, and it affects the oxygen. Why do I see something in front of that? I don't understand. Like I have something that won't go away. That's really weird. Okay, we're just going to keep rolling. Okay, so this 2 right here affects the hydrogen, the nitrogen, the oxygen. So we took into account the hydrogen. Now let's take into account the nitrogen. I have to redo this. So I have to say this is 2 nitrogens in this compound here and 1 here. So 2 plus 1 is 3. Now my oxygen. I have 3 times 2. I gotta get rid of this. 3 times 2 is 6. Plus, I have 1 over here, which is equal to 7. And that should have been a 1. Right? 6 plus 1. Okay, now I look back and I'm not balanced anymore. Right? So let me see, before I try to figure out my oxygens, remember I said stay away from those for now. Let's try to figure out our nitrogen. Can we add something? Can we add a coefficient to make our nitrogens come up to 3? Well, 1 times 3 is 3. So I can put a 3 right there. Now that 3 affects the nitrogen and it affects the oxygen. So we just fixed the nitrogen. Now let's fix the oxygen. The oxygen, 3 times 2 is 6. And then I have 1 here plus 1 is 7. So now I have 3 nitrogens on each side, 7 oxygens, and 2 hydrogens. I am good. Okay, so it's just kind of a stepwise, be careful. Recount everything. All right, next one, we have 2 elements, phosphorus and oxygen. Phosphorus and oxygen. So on our reactant side, we have 1 and 2. On our products, we have 2 phosphorus, we have 5 oxygen. So you could go ahead and start with the phosphorus, or you could start with the oxygen. I'm looking at this and I'm seeing that oxygen's a 5 and here oxygen's a 2. I know that there's nothing that I can multiply this 2 by to get 5. It's not going to happen. So a trick is that you can take this 5, multiply by 2, take this 2, multiply by 5, and get the same answer on both sides. So let's try that and see what happens. So our oxygen on the reactant side, let me go ahead and add this in first. I'm going to put a 5 there. So that just affects the oxygen. But over here on our products, when I multiply by 2 and I put my coefficient in, I'm affecting my phosphorus as well. So I took into account my oxygen. My phosphorus should be 2 times 2, which is 4. Now I know I need to bring my phosphorus up, so if I multiply that times 4, I'm going to get 4. And there I have my balanced chemical equation, because my phosphorus I have equal numbers and my oxygen I have equal numbers. And just be careful that you don't need to reduce. So in this one it's good, but it's kind of a good idea to kind of watch that. Okay, so let's try one a little bit harder. All right, so we have carbon, we have hydrogen, we have oxygen. We have carbon, hydrogen, oxygen. So your first step is to go ahead and count on each side. So here I have 2 carbons, I have 2 hydrogens, and I have 2 oxygens right there. This side I have 1 carbon, I have 2 hydrogen, and I have 2 plus 1 oxygens. Okay, so what do we want to do first? Let me kind of erase all these marks here. What I'm looking for is an element that is only in the products once and the reactants once, right? So I see carbons here and it's not in my other substance, and carbons here and it's not in my other substance. So carbon's a pretty good bet for this go round. So I'm looking to bring up my carbon. So I want to bring this 1 up to a 2, so I'm going to multiply by 2. So I put my coefficient here. I get 2, that's great. But that affects the oxygen as well. Be careful. If I just took this 3 and I said, oh, I'm multiplying by 2 and I get 6, that's not right. That's wrong. So be careful, because you just kind of have to X that out. 2 times 2 is 4 plus 1. So here you have 4 oxygens and here you have 1. So be careful that you take into account the right things. Okay, I'll kind of get rid of that. All right, now, so I have 5 now. All right. Okay, now what am I going to do? Well, let's see. My oxygens don't work out, right? So I know I'm going to have to change that. But I have that same problem where I see that no matter what I multiply that oxygen by, I can't get a 5. There's nothing that I can multiply a 2 by to get a 5. It's not going to happen. So what you could do is just multiply by each other, right? So I know oxygen gives me 10. Okay, so if I put that there, now I need to make 10 oxygen on the other side. I have 4 here and I have 1 here. So how am I going to do that? Well, you got to kind of think about it. If I put a 2 here, that would give me 2 oxygens on this side. So that's 4, 5, 6. But that still doesn't get me up to 10. So what if I put, instead of a 2 in front as a coefficient, what if I put a 4? So if I put a 4 in front, then that's oxygen. 4 times 2 is 8. Is 8. 8 plus 2 is 10. So now I would have enough oxygens. So that's great, but I'm going to go in and I need to fix up the ones that changed, right? So be careful about this. So carbon times 4 now, not times 2, we're times 4. Now we have 4. Oxygen is 4 times 2, so we're changing this again. Oxygen is 4 times 2 is 8. And then we also have to take into account the 2 over here. So plus 2 is 10. Now our hydrogen is 2 times 2. That gives me 4. Okay, let me go back over because I'm not balanced yet. What I notice is I don't have enough carbon and I don't have enough hydrogen. But what can I multiply these by to get 4? Times 2. Times 2, right? So that works out, because if I just put a 2 here, now I've affected both my carbon and my hydrogen, and I've brought them both up. So same number of carbons, same number of hydrogens, same number of oxygens, and it works out. Okay, all right, let's go on. Okay, this is kind of a pictorial description of a chemical reaction. So what they're asking you to do is look at this picture and write a balanced chemical reaction for it. And so what they tell you is the red spheres are oxygen. So if I have two red spheres together, that tells me I have O2. So these two are O2. And then it's telling me if I have a blue sphere, that's a nitrogen. So what I see here is a blue and a red. So I have NO there, right? You could make that one red if you want, right? NO. Okay, so how many of those do I have? Well, I've got that one, and that one, and that one. So how many do I have? I have 4 NO plus I have 2 O2. Okay, and that's going to go to our product. Now in our product, all of our substances, all 4 are the same. I have 1 blue atom, which is nitrogen, and then I have 2 red atoms, which are oxygen. So it's going to yield NO2, and we count them. We have 1, 2, 3, 4. Okay. Does this work? Nitrogen, I have 4. Oxygen, I have 4 here, but then over here I have another 4, that gives me 8. Over here I have nitrogen is 4, and then 4 times 2 for our oxygen, 4 times 2 gives me 8. So yes, it's balanced, but you should notice something. Each of these coefficients is divisible by 2. So really what I should do is I should divide all my coefficients by 2. So it should be 2NO plus 2 divided by 2 is 1, but we don't really write a 1, so I just write O2. And then 4 divided by 2 is 2, so NO2. So there's my final balanced chemical equation. And that's another similar one. So the red spheres are oxygen. So the red here is O, oxygen, and they're 2 together, so that's O2. And I have 2 of them. And the green spheres represent chlorine. So it's chlorine, and I see I have 2 atoms, so that's Cl2. So I have 1, 2, 3, 4 molecules of Cl. So I would write that as O2, and I have 2 molecules of that, plus 4 molecules of Cl2 yields. We come over here. So our red, remember, was our oxygen, and the chlorine's the green. So this is OCl2, and I have 4 of them, right? 1, 2, 3, 4. So yields 4 OCl2. Okay? But what you notice is we're not balanced. And you could check this. Oxygen, chlorine, oxygen's 4, chlorine's 8. Over here, oxygen is 4, chlorine is 8. So that works out, but you need to reduce it. So you would have to divide them all, in this case again, by 2. So 2 divided by 2 is 1, so that would be O2. 4 divided by 2 is 2, so that's 2Cl2, yields. 4 divided by 2 is 2 OCl2. And that gives you your balanced equations. Okay, want to do the same thing we've been doing the whole time. We want to say carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. Carbon, we have 2. Hydrogen, we have 6. Oxygen, we have 2. On the other side, carbon, we have 1. Hydrogen, we have 2. And then oxygen, we have 2 plus 1. Okay. All right. Now, what we can see is that nothing matches. So we need to pick what to do first. So when you're looking at this, you want to pick the elements that are only in one compound on either side of the equation. So I could pick carbon, it's only here or here, or I could pick hydrogen, which is here or here. So it doesn't matter which one you pick, but what I see is that there's a bigger difference in the hydrogens. Compare 6 versus 2 versus 2 and 1. So I'm going to pick the bigger gap because I know I'm going to have to multiply by a bigger number, and so it usually works out pretty well. So let's try that. So what am I going to have to multiply 2 by? I'm going to have to multiply 2 by 3 to get 6. So where's my hydrogen? It's here. So I want to put a 3 there. So I get 6. All right, but that didn't just change my hydrogens, it also changed my oxygen. Now be careful, you can't just put a 3 there times 3. That doesn't work. Don't do that. Lots of people mess up that way. Put a big X on this. That's why I put the plus sign, so that it kind of reminds me that I have oxygen in more than one compound. So I have 2 oxygens here, and then I have 3 oxygens here. So that's 5. Okay, so let me kind of erase these little marks here. Okay, so now I look and I see that my carbons aren't balanced and my oxygen's not balanced. So what I'm going to go through doing is I want to change my carbons first because my oxygen's kind of all over the place. So I want to go in and change my carbons. So I want to bring my carbon up. If I do that, I can multiply this times 2, so I'll put a 2 there. I get a 2, but uh-oh, it's changing my oxygens. So I need to worry about that. So 2 times 2 is 4, plus 3 is 7. Okay, so now my carbons work, my hydrogens work, but my oxygens don't. So what am I going to do to my oxygens to bring them up? There's nothing that I can multiply 2 by to get 7. 2 times nothing gets you to 7. It doesn't work. So you're going to have to find something else to do. So remember our little trick before, our little trick was if you multiply them by each other, right? Put a 7 there, we get 14. So how can I get 14 oxygens on the other side? Right? So what I can do is I can change my coefficients, right? So how to get 14 on the product side, because I have oxygen in 2 places, you want to be a little bit careful, right? What if I change this 3 to a 6, so then I have a total of 6, but I still got to get to 14, right? So I can change this to a 4, so 4 times 2 is 8, 8 plus 6 is 14. Okay, now be careful, we changed a bunch of stuff, so you need to go back and check the other stuff, okay? So I'm going to start over here and I'm going to say, okay, 4 times carbon. So instead of times 2, we're doing times 4. We get 4. We took care of our oxygens. Now our 6. 6 times 2, or 2 times 6, is now going to be 12. So my oxygens are balanced, but that's it. So I want to balance my carbons. So if I put a 2 here, 2 times 2 is 4. So that's good. Now we also have to worry about our hydrogens. 6 times 2 is 12. So we have 4 carbons, 12 hydrogens, and we have 14, but I didn't fix that. So let's go back and fix that. 4 times 2 is 8. I wrote it up at the top. And then plus 6 times 1 is 6. That gives me 14. Okay? So my carbon's good, my hydrogen's good, my oxygen's good. I am happy. And that is it.